Hi, geometry. So let's discuss a little bit of factoring review. First kind of factoring I'm going to discuss is factoring a GCF. A GCF is a greatest common factor. And so let's take a look at example 1 here. I have a 14y squared and a 21y squared. So I look at the 14 and the 21 and decide their greatest common factor, which is 7. And then I look at the y squared and the y to the first, and I realize they both have a y. And so now it's like division. In my head, I'm thinking 14y squared divided by 7y. And so 14 divided by 7 has 2 left over. Y squared divided by y the first has y left over. 21y divided by 7y. 21 divided by 7 is 3. Y divided by y cancels to 1. So I would get 7y times 2y plus 3. And if I went to double check my answer, I could distribute the 7y back in, and I should get the same expression. So how about factoring quadratics when my a is 1? That means the number in front of my x squared term is 1. So in this problem, let's take a look at the first one. The coefficient of my x squared term is 1. So I could use several methods. One of those is the diamond method or the x method, where I write a times c at the top and I write b at the bottom. So a, if I look at this as being ax squared plus bx plus c, my a is 1 and my c is negative 20. So a times c is negative 20. My b is the coefficient on my x term, which is negative 1. And on my side, I try to think of two numbers that multiply to the 20 on top and add to the 1 on the bottom. So when I think about the factors of 20, I think about 1 and 20, 2 and 10, 5 and 4. And the only pair that could possibly give me the negative 1 would be the 5 and the 4. So if I did negative 5 times 4, I'd get negative 20. And negative 5 plus 4, I'd get negative 1. Those are the numbers that go into my parentheses and finish off my factoring problem. Notice we are not asked to solve, we're just asked to factor. What about 2? It appears that my a is not 1, but actually this is a GCF problem. So I can actually factor out the 2, and I would have x squared plus 7x plus 6, for instance. And now I can factor. Let's do my diamond method. A times c on top. My a is now 1. 1 times 6 is 6. My b is 7. I'm trying to think of a number that multiplies to 6 while adding to 7. So I think of the factors of 6, and they are 1 and 6 and 2 and 3. So the 1 and the 6 would allow me to get 6 when I multiply and 7 when I add them. So this 2 is still out in front, and this trinomial factors into, take your numbers from the side of your diamond method, x plus 1, x plus 6. What about factor by grouping? Factor by grouping means that first you group your terms. I'm going to group the first 2 terms and the last 2 terms. Again, first 2 terms, last 2 terms. Once I do that, I look for the GCF in the pair that I grouped. So for number 7, my first 2 terms are x squared and 2x. And they don't have a constant in common, but they do have an x. X squared divided by x is x. 2x divided by x would leave me with a plus 2. Next, I look at the 4x and the 8. And they have a greatest common factor of 4, positive 4. So I'm going to have a plus 4 on the outside. And then 4x divided by 4 is x, and 8 divided by 4 is 2. So when you're doing this method, at this point, what's in my parentheses will match. Otherwise, you can't do it by factor by grouping. So I'd like to factor that term out. I'm going to factor an x plus 2 out of the first term. So I'm going to pull that out. Oh, I did not mean to be writing. I meant to be highlighting. Sorry, this was supposed to look like up above. Let me fix that up with my red pen for just 1 second. Thanks. So I like to factor the x plus 2 out of both of these terms. When I factor the x plus 2 out of x times x plus 2, I would have just an x left over. When I factor the x plus 2 out of 4 times x plus 2, I would have just a 4 left over. And this then is my answer to the problem. So let's go on to the next page and talk about what we do when our coefficient is greater than 1. So when a is a number that's not 1 and I can't take it out as a GFC. Well, I'm going to change to a 4-term polynomial, and I'm going to factor by grouping. So I'm actually going to change it into a problem like I just did. So if you could flip back to the front side, I'd like to change this 2x squared plus 3x minus 9 into a 4-term polynomial. I'm actually going to split this 3x into 2 different numbers, but I need to figure out which 2 numbers work. I use my diamond method again to do this. I put my a times c at the top and my b at the bottom. In this case, my a is 2 and my c is negative 9, so I get a negative 18. And my b is 3. So now I'm thinking of 2 numbers that multiply to negative 18 by adding to 3. The factors of 18 are 1 and 18, 2 and 9, 3 and 6. Oh, there we go. 3 and 6 would work. If I make the 3 negative and the 6 positive, then they multiply to negative 18 and add to positive 3. So now to do this, let me get my blue pen. You keep the 2x squared from the front and you keep the minus 9. But instead of writing 3x, positive 3x, I'm going to write the 2 numbers from the sides of my diamond. So I'm going to write a minus 3x, and I'm going to squeeze in there a plus 6x. Because that is now 4 terms, 2x squared minus 3x plus 6x minus 9. So there's my 4 terms. And the minus 3x plus 6x equal the 3x in my original equation. I just rewrote it in 4 terms. So now I'm going to do my factor by grouping steps. So I'm going to underline the first 2 and underline the last 2. The 2x squared minus 3x have a x in common for greatest common factor. 2x squared divided by x is 2x. Negative 3x divided by x is a negative 3. 6x minus 9, the greatest common factor would be a positive, so plus 3 here. And 6x divided by 3 is 2x. And negative 9 divided by 3 is negative 3. Notice your parentheses match. They have to, if you're going to, oops, not my highlighter. They have to, if you're going to use factor by grouping, because now I'm going to pull out that term that they both have in common. So I'm going to pull the 2x minus 3 out to the front. I'm going to factor it out of both of these. There's my 2x minus 3. So when I take my x times 2x minus 3 term and I factor out a 2x minus 3, they cancel, and I just have an x left over. When I factor it out of my 3 times 2x minus 3 term, I just have a 3 left over, and then this would be my answer. If I'm unsure I've done it right, I could box that or FOIL it. I should get the original equation back if I've done it correctly. So what about difference of 2 squares? So there's a formula for difference of 2 squares. The difference of 2 squares, you find the square roots and you add them and you subtract them, and you're all done. So let's go ahead and do number 19 together. So I think of the square root of the first term, that would be 5x, and I think of the square root of the second term, and that would be 11. I completely ignore the minus sign. So I'm looking for a binomial that when I FOIL it, basically the inner and the outer term cancel. I'm going to do that with a plus and a minus. So this becomes 5x plus 11 and 5x minus 11. Let's look at what happens if we wanted to FOIL that or box method this. Out to the side, I have my 5x plus 11 and my 5x minus 11. So the 5x times 5x gives me 25x squared. The 11 times 5x gives me 55x. The negative 11 times 5x is negative 55x. And 11 times negative 11 is minus 121. Notice the 55x and the negative 55x cancel. and I just get 25x squared minus 121. That, ladies and gentlemen, is difference of two squares. I sometimes call this dots. So if you ever are doing a problem like, oh, that's dots, I mean the difference of two squares. You just square root of the first, square root of the second, and then you plug them into the formula, plus and minus. So what about if it doesn't look like the difference of two squares? Well, number 20 doesn't look like the difference of two squares, but don't forget always your GCF. If I take out a factor of 2, I now have 16x squared minus 9. This becomes a difference of two squares problem. So I hope those were helpful to you. If you have any more trouble on this, please come to office hours and we'll talk about the individual questions. Thank you.